In this video, we're going to have a look at collision theory, and we're going to use it to describe and explain the factors that can affect reaction rate. Very simply, collision theory states that for a reaction to occur, reactant particles must collide, and also when particles collide, they must have enough energy. Now, when we say enough energy, that refers to the activation energy of the reaction. Once particles collide, there are two options. A productive collision, which leads to the formation of products, or a non-productive collision, in which case no product particles are formed. So basically, the more productive collisions we have per unit of time, the more product we're going to have formed within that unit of time. So basically, the more productive collisions in a unit of time, the faster the reaction rate. So factors which affect how many productive collisions are occurring in a unit of time are factors which influence the reaction rate. Because of this, reaction rate depends on the activation energy of the reaction, as this determines the energy that each particle requires before a productive collision can occur. The frequency of collisions, because basically the more often a collision occurs, the more likely it is that there will be a productive collision. The energy of collisions in relation to the activation energy, and the orientation of colliding particles. This is particularly important for compounds such as organic compounds, because you recall within those compounds you've got the functional groups, which is where the reaction occurs. So in those cases, it's important that those functional groups are in the correct orientation to allow a productive collision or reaction to occur. Now, sometimes it'll be favourable to increase the reaction rate. So basically, have your products formed quicker. And if we have a look at these factors which influence reaction rate, we can see that to increase the reaction rate, so to have more productive collisions in a unit of time, it's going to increase if we decrease the activation energy required. The reaction rate is going to increase if we increase the number of productive or the frequency of collisions, because that will lead to more productive collisions. And it's also going to increase if we have a higher energy of collisions in relation to the activation energy. Now we're just going to have a look at the effect that different factors have on reaction rate and the reason it has that effect. Firstly, we're going to consider the concentration of a reactant. And the reaction rate increases as the concentration of a reactant increases. And the reason that the reaction rate increases with an increased concentration of reactants is because there's more particles per unit volume, so more particles within a given area. What that means is that it's more likely that there's going to be collisions, or there will be more collisions per unit of time, and therefore a greater probability of productive collisions occurring. So basically, the more often a collision occurs, the more likely it is that we're going to get a productive collision. The next factor that can affect reaction rate is the pressure, and this is when we're dealing with gaseous reaction mixtures. So basically, the reaction rate is going to increase as the pressure of the reaction mixture is increased. And the reason for that is that by increasing the pressure, you're basically pushing all of the particles closer together, so it's essentially the same as increasing the concentration. So all of those factors that we just looked at for why increasing the concentration increases the reaction rate apply here. So once you increase the pressure, you increase the concentration. Which means that there are going to be more particles per unit volume, therefore you're going to have more collisions per unit of time, hence the greater probability of productive collisions. The next factor we'll have a look at is temperature. Basically, reaction rate increases as temperature increases. At higher temperatures, particles have more kinetic energy. Because of this, they're moving faster and they are going to collide more frequently. The increased kinetic energy of the particles also means that more of the particles have greater energy than the activation energy. That means that more of the collisions are going to be productive. Both of these factors lead to a greater probability of a productive collision, and hence a faster reaction rate. For solid reactants, the reaction rate increases as the surface area increases. The reason for this is that as the reactant has a larger surface area, so for example if you crush it up into a finer powder, with more surface area there are more reactant particles exposed. Because of that, there's going to be more collisions per unit of time and therefore a greater probability of productive collisions. Now, reaction rate also increases with the use of a catalyst. A catalyst allows an alternate reaction pathway which has a lower activation energy. What this means is that there will be more of the particles with an energy greater than the activation energy, and because of that, more productive collisions. Lastly, the reaction rate increases with an increased intensity of light for photochemical reactions. And this is because as the particles absorb the radiation, there are going to be more frequent collisions. And more frequent collisions mean there's a greater probability of a productive collision occurring. So as you can see, there are a variety of factors affecting reaction rate. Some of these factors or effects are unique to different situations. So we've had a look at pressure, which affects gaseous reaction mixtures, surface area, which affects solid reactants, and the intensity of light, which affects photochemical reaction. The other factors will affect all reactions. So that is the concentration of reactants, the temperature, and the use of a catalyst, as opposed to pressure, surface area, and intensity of light, which have a unique effect in particular situations. So just to recap, collision theory states that in order for a reaction to occur, reactant particles must collide, and the colliding particles must have high enough energy, which is the activation energy for the reaction. Once particles collide, there are two options. We can have a productive collision or a non-productive collision. So we can either result in the formation of products or not. And basically, the more productive collisions there are per unit of time, the faster the reaction rate is. Now, the number of productive collisions per unit of time is dependent on the concentration of reactants, the pressure of a gaseous mixture, temperature, surface area of a solid reactant, the use of a catalyst, and for photochemical reactions, the intensity of light also.